All right, so what we're looking at now has to do with still parametric ratios, but this time we're going to look at angles. Now, the reason I left angles to the second part instead of till after the sides has to do with your calculator, really. So first of all, it says find your calculator. First it says using your calculator. It's important that you find your calculator, though, too. And what you need to do is you need to make sure that you can achieve the same thing on your calculator as what I can. So when I'm asked to find a theta, what I have to do is I have to do an inverse operation. So the inverse of a ratio is doing a sine inverse of the ratio, and what will happen is the opposite. You end up getting actually what that angle equals. So if I bring up, and I'm going to bring up the graphing calculator, but again, it's really important that you know how your calculator works. So for instance, I know that my calculator, the graphing one, is always in radians. So I need to do in my calculator, you can see that I have to do, first of all, go away. I need to hit second, then I want sine, which is here, and then I also need to put in the decimal, which is decimal 5869. Oops, should be 69. Okay, and when I hit enter, I end up with approximately 35.9 degrees. All right, so make sure that these calculations that I'm getting, that you're also getting from yours. So the next one, when I do it, I get 34.8 degrees. And finally, the tan inverse of 1.6217, we end up with theta in this case being 58.3. Okay, so it's important, you cannot memorize all the infinite possibilities for sine, cos, or tan inverses. Okay, so you have to have a calculator for it. So let's look at some examples. So it says determine the measure of angle A. So I'm interested in angle A here in this question. Now again, I have kind of a step thing here, whether you use it or not. So I'm going to label the triangle, and the angle that you are finding, which is in this case A, is that theta that we talked about before. So this is kind of the theta that they want. So again, my hypotenuse, opposite of the theta, and this is adjacent. So again, I write down my SOHCAHTOA, and I'm going to underline the sides that I'm given. Okay, this time I will be given two sides. So when I do that here, SOHCAHTOA, some of you already know which one it is, and that's great, then you don't have to do this step. So I have the hypotenuse, and I have the opposite. So you can see right away that it is going to be sine that we're using. Then we fill in the lengths and calculate a decimal to 4 places. So it's a little bit different than the side lengths. It's got a few more steps in it. So I'm going to copy down my formula. I'm going to substitute in what I know. So this is angle A I want to find. My opposite side was 6, and hypotenuse is 10. So it's this here that they're talking to 4 decimal places. I need to turn this to 4 decimal places, which is actually 0.6. There are no 4 ones for here. So now the final step I have to do is I have to use my calculator and do that second or shift function to actually determine angle A. So angle A is going to equal the sine inverse of 0.6, and when I do that, I end up with approximately 36.9 degrees. Okay, so let's try another example. Now in this example, again, the first thing that I have to watch out for. Okay, so what we're looking at now with the next example, same kind of process, we want to label our triangle. Now one thing that I did notice is I know I have 14 feet, but this one here is yards, so I have to have the units the same. So I know that there are 3 feet in 1 yard, so this means I have 9 feet. So now everything's fine, it's a matter of labeling, so you really have to watch out for that to make sure that your units are the same. So here's our opposite, and we have adjacent. So again, when I use SOHCAHTOA, if I need to use SOHCAHTOA, I can see that I have the opposite side and I have the adjacent. So you can see this time I'm going to use the tan ratio. So I have tan of a theta equals opposite over adjacent tan of x, because that's what we're finding. We have opposite, which was 9, and the adjacent, which is 14. So again, I have to change the 9 fourteenths to a decimal, and I do that, and so it rounds to 29, and angle x is going to be the tan inverse of that decimal, of that ratio. And when we do that, we get our angle to be roughly 32.7 degrees. And finally, our last question. Okay, again, I'm going to check that my units are the same. They are. They're inches, both of them. And this time I want to find x, which, so we have opposite, adjacent, and hypotenuse. Okay, again, if I need to use SOHCAHTOA, I mean, when I say need to, if I need to write it down like this, I do so. I have the hypotenuse and I have the adjacent. So you can see that again that we're going to use the one with 2 underlined. So cos of a theta is its adjacent side over its hypotenuse. So cos of x is adjacent, in this case is 1.5 over 3, which turns to a decimal of 0.5. Now to find angle x, I take the cos inverse, and when we do that, we end up with approximately 60 degrees. All right, so there's some questions, or there's some examples for you. So pretty straightforward. You've done that now for a couple years.